Hello, everyone. Welcome to our Get in the Mode podcast. Our guest today is Patrick Bangert. He is the VP of Artificial Intelligence at Samsung SDS. Patrick leads the AI engineering and AI science team at Samsung SDS. His team is responsible for rapidly building AI models and supplying a full spectrum of AI-based technology services to the enterprise. We're excited to talk to Patrick about AI trends that are emerging and quickly becoming mainstream. Patrick, welcome to the show.
Hi, thank you very much for having me.
Patrick, can you start with a little bit about your background? Tell us how you got into the world of AI.
Yeah, I'd be happy to. As a child, I was always interested in how the world works. So then I ended up with a physics degree at university, but I quickly discovered that a lot of the work in physics is figuring out the equation that some system obeys, right? Laws of motion. And figuring that out from experimental data is a very difficult and very time-consuming task that was always very frustrating to me. So I figured there must be a way to automate that. So I discovered back then neural networks, which had already been invented for some time. I mean, we know that the basics of machine learning have been around since the 1940s. So I started a little bit, experimenting with that and ended up getting a PhD in applied mathematics using some of those methods. And I've been in the field ever since.
What is Samsung SDS? Can you tell us a little bit about that? What do you do? What team do you lead?
Right, so I mainly lead two teams. The one avenue is the AI engineering team, and they build software to make AI models. So any data scientist who has a data set and who wants to create an AI model can use our software to do that. And particularly our advantage is to do that very rapidly via several layers of automation. The fundamental layer is distribute the computation across multiple GPUs, up to several hundred of them, so that you can accelerate the process to a very short amount of time. And then beyond that, to use AutoML to do hyperparameter tuning, to do feature engineering, and thereby get to a good model really quickly. As we know, one of the main challenges in AI today is the time delay, simply waiting for the computer to finish computing. And so we accelerate that process by an order of magnitude or two. The second stream is the AI sciences team, and they deal with actually making AI models using datasets, either for the Samsung group internally or to external clients. So together with both of those teams, we really cover the entire workflow of artificial intelligence.
Got it. So you've got the AI science team, which is the model side of it, and then the engineering is sort of the compute accelerating that side of processing, perhaps.
Right. Yeah. We make the tools and we have the people who use the tools.
Right. Now let's take a step back for our listeners and break down. AI is an umbrella term, obviously, and we're talking about machine learning specifically, what you just previously answered. Let's break down the difference between weak AI, strong AI, general AI, so that we kind of dive into some concepts of AI.
Right. Yeah, it's very interesting to think about some of these things. Of course, if we think back several decades, artificial intelligence as such was a word that people coined to think about what would it be like if a machine were as intelligent as we are as humans. The human being can do so many things. They can speak, they can recognize things by looking at them, they can recognize things by hearing sounds, they can remember things that happened years ago. They can stitch facts together and come to a logical conclusion. All of these things are contained in that one device in your head, right? And that's just absolutely mind-boggling how that can happen. And to be truthful, right, nobody knows to this day how that actually happens. There are some theories. And the recreation of that was to be artificial intelligence. Nowadays, that is called general artificial intelligence, right? If we don't have such a system, we dream of having such a system, but if we did, it would be called general artificial intelligence. Of course, the journey to get there is something that quite a few of the universities are researching. And that sort of approach is primarily connected to language. So what people are talking about really is being able to take speech in, interpret it correctly, and then being able to respond with a piece of speech that makes sense. Now that is an ongoing challenge.
Right.
If we are able to do that to the satisfaction that a human being talking to such a system would not be able to tell the difference between an AI system and another human being, that would be the so-called Turing test. So if the system passes that test, if it can behave just like another human being, then that would be a strong AI system.
Got it.
A system that would be considered artificially intelligent. Now, of course, the systems that we have accessible today are not like that. So the systems we have today will solve a much more restricted range of problems. For example, you put an X-ray picture into an AI system and it tells you, yes, you have a broken bone, or you have COVID-19. You put a little time series snippet in it and it will forecast, oh, next week it'll look like that. Things like that are the AI systems that we have accessible to us today, and that's weak AI. In other words, it's not very intelligent. It can just do one task. But that task nonetheless is useful and it's interesting, and it's a level of automation that powers our society. So also, in case listeners are not aware, every day all of us will interact with an AI system multiple times a day. One of those simple restricted applications that solve one thing only. So we can no longer function in the society that we have today without some of these specialized systems. Well, all AI systems, no matter how weak or strong they are, learn.
Learn, yes.
That's what makes AI AI. That you give, basically what you do is you collect some sample data and you provide it to the AI system, and it learns that, whatever it is.
Sure.
But it's an established fact that AI systems and people learn in different ways. So for example, you take a small child out to the forest and you point to the next tree and you say, tree. Now, the child, in some miraculous way, with the one example, just the one example of you pointing and saying tree, the kid will understand what you meant. And then next time, when you encounter a completely different tree, different kind of tree, different looks, different place, it will say tree.
Right.
Yeah, no AI system can do that.
Right.
You have to supply the AI system with thousands upon thousands of photographs of trees, and it will then recognize trees with a probability of maybe 98 or 99%, which means that sometimes by mistake of lighting or something like this, it will recognize a person doing this as a tree. Right. Or you will give it a picture of a small tree and it will say, that's not a tree. It will make mistakes like this. And of course, our human language is somewhat vague, right? Where is exactly the dividing line between a tree and a bush?
Right.
it's not quite certain, right? And for us to communicate, it doesn't really matter very much.
Yep.
But the AI system will draw some very strong boundaries here. And
Yep.
that's one of the main things that still separates the human kind of intelligence or learning
Yep.
from the artificial sense of learning. And here is actually where there is a major source of research right now. It's called small data. You remember the keyword big data from years
Data.
ago.
That's right.
It's like, oh, we have all this data, let's stick it into AI.
Yeah.
Well, now the challenge is, what can you do with very small data sets?
Right.
And that's still a frontier
Yeah.
in artificial intelligence.
What's the level of data that somebody, an organization or a company should have in their data lake, perhaps to, and I'm not sure if that's the right way to approach it, but I'll ask it anyway. If somebody wants to do something with ML or AI, what's the level of data that they should be having in their data lake now that we're talking about small data, right? um,
Yeah.
what are some recommendations you would give to a company that wants to do AI?
Excellent question. Yeah. So, I mean, first of all, it's impossible to give an answer like 1 terabyte, right? Because it totally depends on what kind of data it is and what kind of use case you're going after.
Right.
So, in terms of qualitative criteria, I would say, first of all, use your human intelligence and knowledge to discover what you as a domain expert think are really the informative pieces of data that you should be having. Uh, in data science, we call them features. What are the characteristics that you want, right? So let's take a very simple example. You want to forecast the demand for people to purchase a certain product in a retail store. What are the sorts of informations you might need? You will need the kind of population that lives around there, maybe their age distribution. You might need a database of public holidays. You'll need to know when's the weekend, what month it is. You might need to know the temperature because people behave differently in the winter and the summer. Things like this. There might be a dozen more that you might find interesting. So you would need to have the data for all of those so-called important features for the data set. And while I say always more is better, you need to decide on what you think is a sort of minimum granularity for your data, right? So you need past history of sales, but it doesn't really make sense in this case to say, I need the sales figures every second for the last 2000 years. It will do fine, I think, if you have the daily sales figures for maybe the last 2 years, right? And that, so you have to come up with some reasonable assumptions like this that are based on data science, which is the piece of science that predates or precedes rather artificial intelligence. And that will then tell you what you need. Typically, we find that organizations have of the order of 10 times or more data in excess of the data they actually need. In other words, there are mountains of data that are effectively useless.
Got it. So it's almost like you have to weed out some of the data, and that takes, like you said, identifying those features using human, intelligence, and then realizing, okay, this is the data that we would like to interpret using ML, and then perhaps increase the order of magnitude of that data.
That's right. Now, there are ways of automating this, of course. So if you say, I can't be bothered to search through my huge pile of big data,
Right.
just dump it into an AI system. And I mean, at Samsung, we make an AI system that does things like this, to basically go through and weed out the features that are not informative about your current problem. That's just as interesting as figuring out the features that are informative about the problem. And then, of course, you can search for data points that are effective duplicates of each other.
Right.
Then the second one and the third one are no longer informative about the situation, so they can be removed and things like that.
So let's talk about the subfields of AI, right? Like we said, AI is a very general term. We've got ML, NLP, and various others. Perhaps let's start by defining ML, because that's one subfield that's kind of made leaps and bounds, really getting into the mainstream. So let's start there. The colloquial AI versus ML interchangeably being used. How would you define ML within as a subfield of AI?
Right. I mean, so first of all, colloquially, indeed, these terms are synonyms. So if you read in the newspaper or in some blog about ML or AI or deep learning, DL, or one of these other terms, you can never be sure exactly how the author meant them. And just to prevent your own confusion, you have to assume that they're all meaning the same thing.
Got it.
But as far as researchers in the field are concerned, AI is the umbrella term for everything in artificial intelligence, and machine learning is the subfield that deals with so-called connectionist models. In other words, here we're assuming that we essentially have a neural network, something like this, where you're modeling the situation at hand by simply tuning the values of coefficients in an equation to the data that you have. This is in opposition to primarily the logistic school of thought, which attempts to model a situation by logical rules. Logical rules in the sense of if this, then that.
Yep.
Artificial intelligence originally, and I'm talking about the 1940s, 1950s here, got started with this logic approach. People thought that human intelligence depends primarily on logical thought, which was based on a very few primary ideas that we have, or primary logical constructs, and everything beyond that was basically deduction. And it's turned out in practice that that approach has not yielded very good results, and so it became somewhat disreputable to be in that field. That has changed, by the way, in recent 5 years or so, quite a bit. So there is very significant interest now in merging the connectionist and the logistic approach to artificial intelligence. But that's really where the difference is between machine learning, which is purely based on tuning the numerical coefficients in formulas, to the more sort of logical approach to artificial intelligence. And now deep learning, to cover that term as well, is really where you go from a neural network that has one so-called hidden layer to neural networks that have more than one hidden layer. So it's not really a conceptual difference. It really is a difference in the learning algorithm. There is a methodology, the algorithm, that actually calculates the values of these numerical coefficients that I'm talking about. And that algorithm that we had until maybe 15 years ago ran into trouble when you had more than one hidden layer. Never mind what that trouble was, too mathematical. But there were several people who made some very interesting innovations in mathematics that allowed that trouble to be circumvented. And now we are able to train models that have many hidden layers, and that has yielded a lot more performance. So right now we can say that machine learning is the field of AI that gives models with pretty good performance for these restricted use cases that we spoke about. If you have a use case of doing something very specialized, like detecting a disease from a photo, figuring out, is that thing a tree or not a tree, forecasting a time series, that sort of thing. Machine learning has been pretty good at it, but there is always a certain base layer of inaccuracy that you can't really get rid of.
Right.
And these systems have trouble generalizing beyond their training data set.
Got it.
And this is really why people now are kind of concerned about ML as such, and on its own does a pretty good job, but that's it.
Right.
Now we have to upgrade it, sort of ML 2.0, and that will require methods outside of machine learning. Strictly speaking, it will require some of these logical methods to come in and help out.
Right. So in other words, pattern recognition, we're able to create those models, and then through learning, we're able to update the accuracy of the models, right? And it's almost like there's an intervention that is taking place when we, kind of do that learning as well as updating the models. Future state would be having ML having some sort of DL to be able to do that by itself.
Yeah, something like that, where you would have a model that combines the numerical approach via neural networks and the logical approach via if then kind of rules.
Right.
And you would be able to train that system as a unified whole.
Got it. Now, let's talk about the role of data science in ML, right? So obviously, data science, a lot of data analysis is being done in the ML space. How much of domain knowledge is required by a data scientist? Like, what would you propose to someone who's wanting to do data science in a particular industry?
Yeah, thank you. So first of all, data science is the activity that you do before you do artificial intelligence. That's the activity in which you decide what data to collect. Then you do the actual collecting.
Right.
Then you have to clean that data set by removing all the bad data that were somehow faulty, or you have to clean up because certain data are missing. You have to select your features that we talked about, chuck out the features that are not informative, emphasize the ones that are informative. You may at this point have to generate synthetic features, that is features you did not measure in nature, but that you're going to calculate based on what you measure. All of those are very important preparatory activities. That's data science. And if you look over the entire lifetime of an artificial intelligence project, that data science part, that preparatory step, takes about 80% of the workload. So if you're thinking about it in terms of person hours, the AI is really the fun part at the end. It's the data science that eats all the person hours, right? It's that there where you have to invest the effort. So data science is absolutely crucial for artificial intelligence as a whole, no matter what use case you go after. Now, how much domain knowledge do you need for it? I would say that data science is impossible to do without domain knowledge, first of all.
Right.
You will make very, very basic, silly mistakes if you don't have domain knowledge. And I would say you can only benefit from more domain knowledge. Which is why I always recommend, and I've written articles on this on LinkedIn and other places, that I say I don't actually encourage the data scientist, him or herself, to become a domain expert in whatever domain it is. I recommend them to get a team member who is already a deep domain expert in the field. So I encourage a collaboration between an expert in data science and an expert in whatever domain it is. And for these two people to talk to each other. And also in practice, by the way, it's not generally 2 people, it's more like 10 people. because in real life, any kind of domain is already a bit broader and will need several domain experts in very specific parts of the game plan, right? So again, let's focus on a use case. You want to predict the demand for a certain item to be bought in a retail store. Who do you need for this? Well, you would need a domain expert in marketing. You'd need a domain expert in retail sales. You might need the store manager of a couple of stores to give you some practical cases of what weird things actually happened. So you're already looking at maybe 4 or 5 domain experts from the field. And then you're looking at, a data scientist who specializes in time series forecasting. Yeah, you might need another data scientist who specializes in pattern recognition from some of the non-time series information. You might want to install a couple of cameras in the store. You might need a visual data scientist as well, and so on and so forth. So you're talking about a team effort here.
Right.
So if you're looking to be a data scientist in a certain domain, I actually would not recommend that you become a deep domain expert in that field. Having basic domain knowledge, yes, absolutely. But I think the focus really should lie on communication abilities.
Right.
If you're the mathematician type from the jokes, then you won't be able to communicate with your domain experts. Right. All right. So pay attention to being able to communicate in verbal language, in written language, and of course the holy grail, if you will, of business in PowerPoint slides.
Right.
That is more important than knowing a lot about the domain, because you will have to communicate.
Yeah. Yeah, and let's talk a little bit about the roles here and the positions that are, AI and ML is introducing into our IT industry, right? Traditionally we had the business analysts who kind of liaisoned between the business folks and the technology, technology builders. So data scientist is one, and then they're working with these SMEs that are domain experts, right? What other roles do you see to have a successful data science, ML practice team?
I mean, there is, I think, one person who kind of coordinates the project, right? And you could call that person a business analyst. You could call them a consultant. Frequently, that person is called an architect. Any one of these fancy terms will do just fine. But it's basically the person who envisions the entire project, right? So from end to end. So that would be the data science portion, which involves the data scientists, the data itself, and the domain experts, then moving on to the artificial intelligence, doing the actual modeling, looking at the mathematics to make sure that the model actually does what it's supposed to do, coming up with the right way of checking that the model really is, rigorously solving the problem. And then at the end, communicating back to the end user, hey, we actually solved your problem, and here's a practical way of doing it.
Right.
And then comes the really important part. So the entire thing up to now was science.
Right.
Now comes the really important part, which is to package that piece of AI in some kind of user interface that allows the ordinary individual who doesn't know anything about AI or the problem or anything else to actually obtain the solution in some meaningful way. And that in itself is a time-consuming, laborious activity where you might need to create a new app or an interface or a plugin or something to enable that model to do its job.
Yeah, a way to visualize the findings, right?
Yeah.
For the end user. Now, let's talk a little bit about the fields of AI or the industries that are successfully tapping into ML, specifically. Can you, from kind of the crossing the chasm example, what are some industries that are going to see some sort of a mainstream, usage of ML, and then benefiting it from it with ROI, within the next 3 years, perhaps?
So, I mean, I think probably the first industry that adopted AI heavily and received lots of benefit classically, and in this case, of course, is the military. They're always at the forefront of technology. Soon thereafter, I think, came retail. Definitely, there's a lot of retail use cases that you can imagine. For example, the prices that you pay nowadays in retail stores, they're calculated by AI. How many units of a single item are on stock on the shelves and in the back room in any store, that's determined by AI. How many cashiers are currently staffed, that's decided by AI. When are the store opening hours? How big is the parking lot? How many square foot does the store have? Which products it contains and does not contain is all decided by AI. When the stocker has to come and refill the shelves is targeted by AI based on a camera that's in the store. All these things are AI-assisted tools in retail in the actual store. And then, of course, as we just said, we have models that can forecast what the audience is going to buy in the next few weeks and months. So that decides how many units are going to be shipped out, and it decides how many units are going to be produced. So I've personally done models, for example, for clothing chains that said, okay, next season, 6 months out, how many of each type of clothing should we produce? Right. So then you decide on that, and then that's your stock. So you have to be pretty sure that you can't sell more, but you also won't sell a great deal less than what you forecasted. Difficult problem. It's a huge investment. Put up $1 billion in stock, and you better sell that. So retail has definitely embraced AI very much. Currently, the industry that's most promising, I think, for the next 2 to 3 years, like you asked, is healthcare. We have a lot of healthcare applications, particularly in the image-based sector. So X-ray, MRI scan, CT scan, photograph of a part of the body to diagnose diseases, to track diseases over the long term, to do telemedicine without you being in the same physical room as the doctor. Things like that are now being researched quite heavily and to some extent already deployed at hospitals. So that definitely within healthcare, you can look forward to a lot of results.
Now, we've talked a lot about ML. NLP is another subfield, right? But typically, AI practitioners see that as a black sheep. Why is that?
Yeah, so you've recently heard, I think, the release of a new natural language processing model called GPT-3.
Right.
And the discussion around that really highlights some of the difficulties. And it really comes down, I think, in my opinion, to two major items. First of all, the cost of training these systems. So one training loop of GPT-3 cost apparently $5 million. Now that's $5 million basically in electricity cost and in rental cost for the graphical processing units, the GPUs, that compute this model. It's not the purchasing of the GPUs, it's the renting of the GPUs for the amount of time it took, right? So you're talking about a gigantic financial investment in training NLP systems, and therefore NLP training and research on systems like that become impossible for anybody but the largest of commercial players. Universities can't do it anymore. Startups can't do it anymore. Mid-sized companies would struggle. It's really only the large players, the usual names that everybody knows, that can afford to engage in that area. That's problem number one. And that, of course, leads to monopolies and such.
Right.
The second problem is that when you look at the output of these systems, your first thought is, hey, that's pretty good. And your second thought is, hey, that doesn't make any sense. The trouble is that what comes out of these NLP systems is, in fact, a fully formed, grammatically correct sentence with good vocabulary. It sounds reasonable. You know, the cadence is about right. The words that they're using is about right. And if you ask general enough questions or say general enough things, you'll get some pretty meaningful responses back, right? If you talk about your feelings, for example, then it sounds about right. Because what are these systems trained on? They're trained on written literature that was written by people. However, dare ask any specific question, and you quickly put the model into trouble. Right. So the first thing to do is to ask any arithmetical question, right? I've got 3 apples and 4 pears. How many fruit do I have? I don't know any system that gives the right answer to that. Right. Or ask it about time, right? It took 1 hour to do this and 3 hours to do that. I started at 12. What time is it now? Right. I don't know any system that gives the right answer to that. It's very clear that these models do not understand in any meaning that we put to the word understand anything that they're talking about.
Right.
They are just black boxes that take a sentence in and put a sentence out, and it's a reasonable sentence, but if you're looking for content, no can do. So with respect to the Turing test that I mentioned earlier, you know, talking to the system and you not being sure, is it a system or a human? These systems definitely fail quite miserably, and they would fail in 2 or 3 questions if you ask the right questions. The field is moving more and more in the direction of larger data sets and larger models, which makes both of the problems I've explained worse. It increases the financial cost of training these systems, and it does not go at all towards improving the understanding or the meaningful reasoning behind these systems, because there is no reasoning built into them. It is purely what we said is machine learning, purely a coefficient-driven model, and there is no logical understanding of concepts or logical reasoning that is built into the system. And this is the crossroads that we're at right now. Is I don't believe that we will make any meaningful progress in NLP with the types of models that are currently deployed. I think in order to progress, we need this unification of machine learning and logical reasoning.
Now, autonomous driving is a hot topic at this time. How far, what are some last finishing touches that are happening in that area, before it, we're right on the verge of producing returns? What would you say is the last finishing touches on that?
Autonomous driving is, I think, the field that makes up for half, if not more, current financial investment and person-hour investment into AI as a whole. So that's the biggest use case in the entire field by far. And the research, I think, is largely visual. So there is various image generating capability, not only camera, but LiDAR and range measurements like that involved. So several problems like recognizing traffic signs and interpreting what they are, recognizing obstacles on the road and deciding whether they are people or animals or hard obstacles, deciding where is the lane, which lane should I be in, traffic lights, turning, and so on. All those problems have been solved.
Right.
So that goes into these so-called levels. All right, there are levels of cars. So level 0, for example, is you have no automation whatsoever in the car. You have to drive it yourself. Level 1 is you have some nice assistance features for the driver, like you have some cameras and stuff like that. And level 2 is you have some automated braking, some automated lane assists, things like that. Level 3 is the car can stay in its lane on its own. It can maybe park on its own. Level 4 is you can get from A to B completely autonomously without human intervention, as long as both A and B are within quote unquote civilization. So you have lane markings, you have proper roads, things like this. Level 5, which is the ultimate goal of autonomous driving, would be getting from A to B no matter where A and B are.
Right.
Right. So A and B could be out of civilization, could be off the road.
Yep.
No lane markings, no physical asphalted road available anymore, a dirt path in the forest, right, up a mountain, down a mountain, right. That sort of thing. And that's still a research area. So what you can purchase today, you can go out into to a car store and actually buy is level 3.
Got it.
Roughly.
Yeah.
That's where we can debate, whether it's level 2 or level 3, but I would say it's level 3 that you can actually buy.
Right.
Level 4 is something that I think will be available for purchase in the next 2, 3, 4 years.
Yeah.
And at that point, what you will see a huge shift. So what we saw, for example, with the advent of Uber and Lyft, basically the death of taxis, you will see that again in the death of Uber and Lyft, in the sense that the human driver will become obsolete at the point of level 4. It will be a car that genuinely drives itself. There will be cars without steering wheels or pedals. You simply sit in them and you tell them where you want to go, and the car takes care of the rest. As I said, as long as it's within a sort of civilized environment. And these cars are being built. Companies are already in existence that are well funded that are making these. So prototypes are already on the roads now, especially in California. So this is not far off anymore.
Right. Now let's talk a little bit about Samsung SDS. In your AI portfolio of programs, what do you guys have? What's your roadmap for 2021?
So we're focusing mostly on establishing tools that help the AI journey. So anybody who wants to train an AI model, we supply the tools to do that in a very automated way. So we use AI to automate the AI process. And the biggest element that we're currently focused on is data labeling. Imagine if you want to train an AI model to underpin, for example, autonomous driving, then you need to collect a lot of photographs of events that happen on a road. For example, traffic signs, people on the road, animals on the road, obstacles on the road, lane markings there and missing, traffic signs that are clearly visible, traffic signs that are obscured in some way, and so on and so forth. And then you have to identify, typically by human means, so manually, where is that, right? So, okay, the traffic sign is here, and by the way, it's a stop sign. And a person is here on the road, danger, and so on and so forth. That annotation of those images is extremely time consuming. And currently that's, in fact, a sort of cottage industry with quite a few tens of thousands of people data labeling as a full-time job. And our biggest focus at the moment at Samsung SDS is to automate that process. And we've shown some really excellent results where we can reduce the effort by over 90%. And we can afford to label only 10%, maybe 15% of the data with the same information content as if you labeled all of them. So you can imagine what reduction that means in terms of person hours to label the data set. Yeah, you go from 100% effort down to 10 or 15%. effort in data labeling. And we're talking about hundreds of thousands or even millions of images that need to be labeled for realistic use cases. So that's months of time saved. That's our primary thrust into the field. So anybody out there who wants to label their images, come see me. After that, then comes the stages of feature selection, feature generation, like we talked about, to tease out the last bits of information from that data set. So we've automated that process as well, so that you simply stick in your data, wait for a little while until the AI discovers the right features to use, and then you can do what's called hyperparameter tuning, which is to adjust the parameters of the AI learning algorithm in the optimal way to get the right result. And all of that is, of course, underpinned by the infrastructure of being able to use hundreds of GPUs simultaneously, either your own or on the cloud, to make that entire training process really fast. So we're primarily in the business of reducing both the human effort that goes into a project as well as the duration from beginning to end of the entire AI process with our tool set.
Makes sense. Tell us a little bit about how approachable is ROI in ML or any of the AI subfields. Um, you know, what is kind of the tipping point? Where are we on that?
So in terms of return on investment, for any particular use case, I think AI is definitely a very good investment. In the sense that the investment that you make in anything artificial intelligence is really at the beginning. You invest in the creation of the AI model that has a certain cost, and this cost is very predictable. So a priori, you can calculate how much it's going to cost you to make that AI, and you know what your investment is. And then after the AI model is produced, it's really then a piece of software that you can execute. So it scales very easily with very little additional cost. And so if you have an enterprise that is able to scale, like you have thousands of retail stores or tens of thousands of autonomously driving cars or anything like that, you can scale that model across that fleet very easily with relatively little cost. Supposing, of course, that the AI model is accurate enough, then it would also be quite easy to calculate its financial benefit to you in advance. Part of the financial benefit is definitely automation. You can save a certain amount of human labor, perhaps machine labor, perhaps even data acquisition cost through the use of artificial intelligence. But you can also save a number of other costs depending on the use case. So for example, again, if we're talking about retail, you can save delivery cost, production cost, raw material cost if you only produce the right amount of units, ship them to the right places in the right amounts, and so on. So it is, on the one hand, cost savings in a variety of areas, but it can be revenue generators in a variety of other areas as well. So for example, again, retail, if the AI is in outbound marketing, you can target specific individuals who have a specific interest in one of your products and point that out to them. You will increase your sales for that particular unit. And then you can generate an additional revenue income. So you have both a cost reduction as well as a revenue increase, both of which are predictable because, again, AI will do the predicting for you, so that your investment is, first of all, relatively secure. Of course, there's always risk, but the risk is calculable. And the return is generally quite large.
Yeah.
So some of the very initial use cases, even in the 1980s, they produced a return on investment after 1 or 2 weeks of rollout. So you can imagine investing a few $100,000 or a million or two in building up an AI system, and you can expect that to be returned to you after you've installed it, probably within weeks.
Which is quicker in your opinion? Is it the cost reduction portion? I mean, obviously RPA is a big player in automation, or would you say it's more the targeted sales enablement side of things, or it depends? Would your answer be it depends?
Well, it depends on the use case.
Yeah, yeah.
Of course. So if your use case is calculate the right production amounts, it's going to be a cost saver.
Right.
If the use case is do personalized sales outreach, then of course it's a revenue
Yep.
use case. Of course, if you have a large retail chain, I would personally advocate to do all of those.
Yeah.
They will mutually assist each other, right? First of all, you produce the right stuff, and then you market what you've produced, and then it's a mutually reinforcing
Right.
system.
I think the ability to create those economies of scale, right? That's the key there, especially for retail. It's not just sales enablement, but also kind of exponentially increase it. As far as cloud providers goes, you've got AWS, Google, as well as Azure, Microsoft, um, who are doing some interesting things, for practitioner or folks that want to get into AI, digital leaders that want to get into AI. What are some interesting things that they need to consider with each of these cloud players?
So each of these three cloud players, as well as others, supply you with the computational infrastructure to do AI. They supply you with the GPUs, the computers, the storage. They supply you with many of each, so that you can scale on the infrastructure. That's their first and foremost business model. They will rent hardware to you.
Right.
What you're going to do with that hardware is really up to you. Some of the cloud providers, in addition to that, will sell or rent you software that does some parts of the data science or artificial intelligence lifecycle. On Amazon Web Services, AWS, you have the SageMaker product. On Microsoft Azure, you have the so-called cognitive services. You can use those. However, they are not, let's say, user-friendly in the sense that somebody who is not an AI expert has no hope of using them very well. So if you do your AI on those platforms, you need to have staff that is highly educated in artificial intelligence, and as I mentioned, assisted by staff that is domain experts in whatever field it is. And them working together can use that software tool set on that hardware platform. There are other software tools that are not made by the three main hyperscaler cloud providers. Samsung is an example, but there are others as well that are much more user-friendly, that will allow what is usually called a citizen data scientist. In other words, somebody who has a pretty good knowledge of data science and AI, but is not like a PhD expert in it, to use those softwares to produce a meaningful result in less time. And those softwares are out there. You can typically install them on one of the cloud providers. So you can still use one of the hyperscalers as their hardware base, stick the third-party software on it, use your own data scientists to do that. And of course, in addition to that, if you don't feel like hiring a whole team or you don't have one, there are, again, a multitude of companies out there who will basically consult with you. Again, Samsung is one, but there are plenty of others who will then provide a team of data scientists to do the actual work.
What's the name of Samsung's offering in the AI space? Like you were saying that it enables citizen data scientists.
Yeah, our major product is called Brightex AI Accelerator.
Got it. Okay.
If you go to the AWS marketplace and you type in either Brightex AI Accelerator or Samsung SDS, you will find us.
Great. Patrick, it's been a pleasure chatting with you on AI and topics such as ML and NLP. Really enjoyed it. I'm I'm sure that our audience will, and get a great deal of benefit from listening to this. Thank you for being on the show.
Thank you very much for having me. It's been a pleasure.